And there's lots of stuff to go through today. So we're going to wait. Yeah, I have to wait for the people to reconnect. But while I'm getting started here, while those people are connecting, just a reminder, https://github.com/rbxrob/boost is where the outline is that we're kind of maintaining. Just a reminder on the schedule, 6:30 to 7 every night is AMA. You can just come in and shoot the breeze and listen to music, drink coffee. And then at, promptly at 7, we're going to get going with whatever the boost topic is for the day. The boosts have been reduced to 90 minutes as of yesterday. And thank you. And based on that leaves 6.5 hours per week of video to watch if you want to keep up with us. You can, fast forward it on the weekend if you want. If you can't, stay with us live. Of course, if you can, with 6:30, it's going to be 7 to 8:30 every day, every weekday. And then again, on Sunday, Saturday, we're adding something. We're going to play Shenzhen in the afternoon. That's all on the live calendar on Twitch if you want to go check it out. It's also, that's the best place to go. You go to get my GitHub. GitHub.com/rbxrob has all of the information about what's going on. I'm going to refresh and see if we've got a few more viewers here before we get going. I know these 90-minute videos are still pretty long. I do intend, the highlighted videos were really popular, but they take quite a bit of time to make. So I am trying to mark every video and then get to you and talk to you, and then be able to go back and mark out the relevant stuff from the video. So you can just watch the stuff you're interested in. But if you want to do that anyway, you can just go straight to the outline and you can see exactly what was covered on what day. I'm going to start putting in the title. I'm going to put the major theme for the day. And today's theme is the great reveal. Understand pipe sockets and redirection. So what are those things? And so I'm going to give you an overview. I'm actually going to go ahead and start a video right now. Yeah. Streams. All right. So this is going to be the first video we're going to make. I have to do these pretty fast so people can stay focused, but I am kind of doing this as we go. And again, if you have questions, ask them during the AMA time. If you have a relevant question to the video, please ask or please interject if you have something to add. If you're in the chat and you don't want your stuff to appear on the screen, just put an exclamation point in front of it. Okay, so ready, go. So the first one here, I'm gonna take my headphones off. I don't need those on. So the first topic is streams, streaming. I'm not talking about live streaming. I'm talking about sending data in different directions. And to really truly understand computers in general, you need to understand that everything is a stream of ones and zeros. And you can imagine those ones and zeros traveling. They're being received, or they're being sent in response. It's going over the internet. It's true that, like, if you've ever seen one of these crazy advertisements where they have a bunch of ones and zeros going all over the walls and everything. It's like everything is digital, that kind of thing. Well, it actually is true. Everything in a digital world boils down to a 1 and a 0, and those ones and zeros are traveling in different directions. So understanding streams, in fact, it became such a big deal. It became such a big deal in the C++ world that they created a C out and a C in stream, and you redirect, the data to those streams. So there's this idea of things getting passed around. But so there are three main streams: standard input, standard output, and standard error. And we're going to talk about what that means, and that'll help you get a sense of it more. Again, the purpose of Beginner Boost is to show you what you need to know, not necessarily, show you everything about it. You need to do your own research and stuff, but in some cases it's a little bit easier to just kind of give it to you quickly, grok it out. So let's start with a command here. Let's start with the echo command. Oh, so by the way, do you guys have your Docker? Which Docker we're going to use today? So you can use an ephemeral one. I'm actually going to use a new one. You don't have this command now. I just added this command today. So I'm going to add streams. I'm going to add a new streams workspace, and I'm going to teach you how to use this workspace later if you want to use my workspace instead of your own. But so this gives me a brand new workspace on a new container that looks a lot like that's on my same computer, right? Because it's my workspace. Anyway, so let's do a stream. So if I'm going to do, well, let's see here. Why is that even there? I think we could probably make that something else. Anyway. Okay, so echo something. Right? I might just go back. I don't need it. For this stuff, I don't need it. So echo something. I don't know. Do we need it? Open streams. All right. So echo something. Echo is a print. It prints whatever it is to the standard output. Now, when we say print, it's important to know that when we say print, we don't really mean print, but in computing, people say print all the time. This goes back to the teletype days. You can go watch the old videos on that. But printing really means send it to standard output. That's what it means. And so instead of saying print, there's actually a print command. If you use print, it'll say, "I'm sorry, I can't print to the printer. There was no printer." Well, that's because if you want to print, you want to do a printf something, right? And that will, if you want to do that, you have to put a line return on there. And I should probably put that in the and printf to print stuff. Okay, so there we go. We've got that standard output. So standard output goes to the screen by default, and it actually literally goes to the screen. Remember we looked at the devices in the /dev, right? There are the TTY devices in here that the stream of ones and zeros that make a letters something goes to that, and that gets interpreted by your screen, your teletype terminal emulator, and it displays it that way. Now you can send a lot of things to the stream. You can send things that cause color. You can send stream digits that say to backspace to send a bell, a noise. All of that is just a bunch of streaming that gets redirected to the terminal, and then the terminal knows what to do, including all the graphics. Graphics is also a stream. It's just a very high performance stream of data. So that's what's going on there. Send EPUB to lest. Yeah, you probably could. Which is usually a zip file. Yeah. Well, so there's lots of things going on here. And so echo something. I mean, I don't need to make this fancy. It is probably worth mentioning that you should probably put quotes around stuff if you have spaces in there, right? If you don't, you get in trouble, but it'll try to do the best if you don't. So that's just the first way to stream is something to the screen. Now, there is another stream that we can send to. So if we want to, another one is called error, standard error. And it's harder to see standard error because it also goes to the screen. And because it goes to the screen in this case, it's used for error messages that you don't want to be. So let's say you're actually printing something like we talked about, like sorting through file data and something, right? Well, maybe one of those lines is not valuable. So a common problem with this is let's like search everything on the computer here for a file with the name that ends in Markdown. MD, anything that ends with the mark, and we haven't done find yet, but I kind of like using these as an example. So this is going to produce a lot of output. So see, here's all this stuff, right? But a lot of this output is like really annoying. And that output is supposed to be helpful. It's like you don't have permission to see that, right? Now there's a way to get around that. I'm going to show you in a bit. But if we do it on stuff that we can see, we can do find on the current directory, and it will show us all the names, and then it sends it all to standard output, right? And we can see it. Now there was no errors there. And I'm going to get to redirection in just a second because I want to show you that this output is different than this output, even though it's a different area. The point being, some of that data is going to the standard output and some is going to standard error. So how, here's a practical problem. I want to do a find, but I'm sick and tired of seeing all these permission denied errors. I want to make them shut up. So what you can do is you can say, I want to redirect the permissions errors to a file. I can say, I want to still read the file. Okay. So the way we do that is the redirect operator. And so to first understand the redirect operator, let's do the redirect operator just on the main. Let's do the redirect operator only on the main standard output, right? So we could do find dot and that'll just list all the files. It's a fancy way to list, really, recursively. And so we're going to find it, and I'm going to write with a greater than sign. Now that is not a greater than sign. It means redirect and overwrite. All right. Now at this point, I'm going to set clobber on because I think I have clobber off. You probably have clobber on. Anyway, so we're going to do find dot, and we're going to send that to find dot out, which is a pretty common thing to name. It's not required, but that's a pretty common standard name for stuff that's come out of a file. You see how it didn't print anything to the screen that time? That's because it's going to, oh, my Vim's not happy. Give me a second. So I got to fix it. So here's the file that it wrote to. See this? It's got all this find.out, and it's all in this nice file. So it's like how many lines? 45, 50, 60 lines. And you can see everything that you need to see there. All right, now let's try that same exact thing. Let's try that same exact thing we just did, but let's do it with that other find against the root directory that has all these permissions problems, right? So we can't see stuff, so it's creating errors. So let's do find slash, and say, well, we got, okay, so there's all those files, right? And then, but there was obviously some things that were not seen there. Let's do type F just for all the files only. All right, so there we saw some more stuff. That one didn't have as many errors, or they did. They just got scrolled off the screen really fast. So let's do this. So if we do find and we pipe that to more, we've been doing that already. See all these other errors that are in here, right? So we got those errors, and it's actually not messing up the output. I'm going to prove it right now. It's just messing up the terminal that you see. So let's try it. Let's do find, and let's write it to a file. So we'll do find.out this time again. And what? Why did it still print stuff to the screen? Well, it still printed stuff to the screen because that's being written to standard error. All right. And we can actually redirect that as well. We could say, I want to redirect error. Now, error is a special file descriptor named number2. So we're going to say, I want number2 to go to find.error. And now I have, you don't have to have spaces on that one, but now everything has been redirected, right? And so now we can look at, let's do more find.out. So there's all of our find.out stuff, right? We learned WC, so let's count how many. So there's a lot of files in there. Let's do more on find.error. Did anybody play Over the Wire, by the way? It's got a lot of the stuff in there. So here's all the errors. So this is just the errors, right? Now, if for some reason we wanted to combine those together, the standard output and the standard error, into one file, I don't know why you would do that. It'd be annoying, but you can. You do the same exact command, only this time we find out both, right? Redirect everything to find out both, and then after that, and this has to be in the order, /routes standard output. No. But the slash is just a find command. So find slash says find all the files in slash, and there's a lot of them. And then this is where it gets redirected right here. This is what's doing the redirect. Yeah. All right. So then now we're going to say I want that, but I also want to. Remember before we had. And by the way, another way to do this this is just shortcut. This is a shortcut for this, because output 1 is the same. So then they're called file descriptors. So standard output has file descriptor 1, and I believe it's a file descriptor. I might be wrong on that, and 2 is the stream for error. And you can leave 1 off if you want, because it's so common to do that. So let me just make sure I'm not lying here. Let me go check. Yep, there we go. So that is sending, the error and output to those things. Now let's combine the two. So we're gonna do find slash, and this time we're gonna do find.out. And then we're going to say, I want 2 to go to 1. Now you'll notice when you're using a file descriptor, you have to push an ampersand in front of that. That's what that's called. That's the capital shift number 7. And when you do that, find that out is going to have lots of stuff in it, but not just what we want, right? Let's see if we can find any of our errors. Do we get any? Permission. Yeah, there we go. See? The thing that's really crazy about this is, look, it actually isn't even in any particular order. Yeah, it's usually, sometimes it depends on the program. Some programs will interrupt the other line that the other one's writing. So you want to think of those two streams as separate. Don't cross the streams, they say. They do cross the streams when it comes to you on the terminal. And that can be very frustrating, because you're trying to look at something and then the error thing will show up. You're like, just go away. And that's exactly what find is one of the common ones where that's a problem. Now you're going to run into this idea of streams, of standard output and standard error and standard input in everything you do, not just on the command line terminal, but in programming. This is a common thing. It's all throughout everything in every operating system. Standard output, standard error, and standard input. So let's turn the tables a little bit and talk briefly about standard input. This is all here. Rev is fun. So we'll talk about that in a bit. Let's put this one up here. Let's actually, before we leave this, let's talk about printf for a bit. So printf will print something, right? You can use double or single quotes. Double quotes allow variables inside, which we haven't talked about yet. So that prints something. If you ever do this, though, you probably are going to want to put a line return. The short rule is, if you want to print without a line return, use printf. If you do want a line return, use echo, even though echo has a switch for that. It's not POSIX compatible. So just if you want a line, use echo, or you can use printf. I gotta be careful with echo. You gotta always be sure to put stuff around it. I don't, because I get lazy sometimes. Now printf has the additional cool thing of being able to say cost. You can use this replacement thing, which is all over in other things too. S, right? Date, %S, and you can read all about it. I'm just giving you a sense of it. And then over here, the next things need to be those things. So you could say, $20, $59, and then on the date would be, we can actually use backtick and put date here to replace it with the actual date. And so there you go. Actually, I screwed it up because date has more than just one thing. So let's do this. Let's do I don't want to confuse you. I mean, you can just put Monday in there if you want, right? Let's just do that. So just put Monday, and you'll see there. So it replaces it where it's at. It's very useful when you're trying to create reports and stuff like that. There's variations of printf everywhere. Every single language has it. Go's is particularly beneficial. In fact, with Go, you can print binary 0 and 1 representation using it. It's pretty cool. It's the only language that does that, by the way. And so let's go back to our talking about the streams and how that plays out. So we've covered printf. We did the redirection. We haven't done the pipes yet. We haven't done input. So before we leave this redirection, let's talk about appending. So sometimes, well, we might as well, I mean, reverse doesn't really go here. We just leave it. It's not really useful. It's kind of fun, but not useful. So we have this one too. Let's leave this one here. I'm going to put, after this one, I'm going to show you how to do, use find, with redirection. We did that. Rediction. Okay. I hope you guys are playing around with this on your own too, like in your own containers. So there's another one. It's called append. So if you have two of them, then you can write to something you already had. So let's actually use something simpler. So let's say echo date. Well, no, let's like make a log entry, shall we? How about that? So let's say printf, and then we can say, if you put a backtick in there, it'll actually put the date in. Well, no, let's do this. I don't know. I'm just thinking here. Let's do this. Let's do this here. We'll do an S for that, and then we'll put what happened, and that'll be like our event. So over here, we'll do this, and then inside of here, we're going to put the date, and then we'll have a colon, and then the second thing will be what it is we did, something to a string, right? Yeah, it does. So now we probably want to put a line return in there because that's like off the screen, right? Now that's actually kind of a long thing, so I'm going to change it from date to a program I called isosec, and that just prints out our second. Why is that not? Oh, I put it in the wrong place. All right, so there's our isosecond, right? If you want an isosecond command, we could actually replace this with the long form of that, and I think it's I don't remember, date-co. Anyway, so we just put date for now if you want. That's fine. So something, and then we can do something else, right? So this is kind of like a log. It's writing, it's updating the time and everything. Well, what if we wanted to have that running and like writing to a log? Well, if we do this, we're going to write it to log, right? So this log file. Okay, and then we can cat the log file and we see, hey, we have a thing there. Well, if I do it again, then what? Oh no, now it's broken, right? By the way, you can actually watch all of that. I think we can put it all in quotes. Nope, doesn't work. Never mind. Forget I say anything. It's a little bit more involved than that. The point is that we have a log now, right? But it keeps getting overwritten. It's like, I don't want it to get overwritten. So we're going to append to it. So instead of doing one left bracket, we do two. And two left brackets writes to it over and over again. Yep. And you can just, every time you do it, and now when you cat your log, you see you got stuff in there. Okay. So that's all. Now, if you have clobber set, I want to say that I do. And you try to overwrite the log. I don't know if I do. I might turn off by default. I do. And what is it? We got to turn off no clobber. I got to go search for it. Disable no clobber. I'm going to go to search the internet. So by default, on your system, you probably will have clobber on. And what that means is you can't override stuff. Now, in my workspace, I've turned it off because I use it all the time. You got to be really careful. It's one of the more subtle ways to destroy your work is to accidentally overwrite it with something else. I think it's option, but I don't remember. I'm gonna go look for it. Echo, yeah, there it is. Pipe or bang, and no clubber. Is it just no clubber? You guys know? No blubber. I don't remember. Someone tell me. Well, that didn't error out, so I don't know. Let's try it. So, oh wait, I was in the wrong place. Set no clubber. Touch file. Echo sum to file. No, it's not on. Someone figured it out. I don't know. I should know. I should research this. Mine's off all the time. Sue me. I could probably look at my bash RC. Let me go look. No, I don't want to do that. Turn on. Now, if you're a beginner, you might want this on. That's what I want to tell you about it for, because it does protect your files. See if I can find it really quick. Is it set-o, no clubber? It's -o, right? I missed the O. Thank you. Thank you. I was missing something. Set-o, no clubber. So that should be on by default. If you put clubber on, so now if you have a file, it says, nope, sorry, can't do it. And that's why you have the clobber operator. That's what I call it anyway. If you want to really clobber it, you can put the bar on there, and now you can clobber it. Okay, and that's all that is. That's it. Knowing that, I mean, it's probably safer, particularly for beginners, to have clobber activated. It is by default. So if you want to turn it off, you would do set-o clobber, I think, to put it back. And now you can kill. It's not a clobber. Set, I think is it -o? I wonder what it is. I don't even know. I don't know. All right, let's just do set, see what happens. No. It is off by default. Yeah. It is off by default. Mine is on. Mine is off by default. Is it +o? I can't believe I didn't know that. You know what? I always confuzzle my TTY settings with this. Plus no clobber. All right, so now we can do that again. Let's do it. Thank you, Mochikomi, for the rescue. Well, you know, I haven't used this for forever. So, but now, well, see how it just let it go. So that's all. Files will clobber by default. All right. Well, now you know. Now you know how to set no clobber if you want, and you know about the streams. And we are just about done with this video. So we still have to talk about standard input. We're going to make standard input into its own thing. And because there's just so many ways to do standard input and output. So we'll separate that into a separate video. The last thing we haven't learned yet is the pipe operator. We should probably do a video on pipe all by itself too. So let's do that. Let's do standard input. Standard output and standard error. Standard output and error. We'll put these together. And then we'll say understanding standard. So understand standard, or understand pipes. Okay, so pipes and pipelines, and we'll do that in the next video. You'll like it. Pipes and pipelines are fun. All right. Stream marker. All right, get up and walk around, people. Let's walk around. Take a 5-minute break, huh? Oh, my fishies are off today. They're not as good as they were. I'll be right back. All right. A couple of minutes here still. Any questions? Any questions or informal things? I mean, pipes are pretty basic, but they're super fun and super powerful. And they are so great for little projects. Amen to that. This is how you can make like your utilities and your story games and all of that stuff. Comes down to this standard input and output stuff. Tea this time. No coffee this late. I could have bet the other day. I think you guys are ready. You guys are all ready for the next thing, huh? Okay. Well, let's do pipelines, and then we'll do standard input. The output stuff apply. Bash, sh, Python, everything. Yep. Nope, it's everything. Yep. Output, input, and it's all there. It just depends on the. So you're talking about the exact syntax. So the exact syntax, the greater than, a double greater than, all that. That syntax is universal to anything that claims to be an interactive Unix shell, pretty much. So bash, Z shell, the POSIX shell, sh, dash, ash, all of that. They all use that. Yeah, let's do pipes. All right. So, all right. So, it's a me, a Mario. Pipes, exactly. We kind of need pipes and pipelines. We do. We really need a Mario. It's a me, a Mario. Somebody who said that. Session AM said that. That's a great reference. And pipes are a blast, but they're not as fun as standard input. We're going to do that next in the next video. This will be a short video, but I want to make sure that I call out the reference to the Unix YouTube video on this before we get on this. So Unix YouTube video on Ken Thompson. We actually watched this and did a full commentary on it. It was really, really fun. If you want to watch our version of it, I think I might even be able to get it for you on video. Vids, Ken, I think I don't know. I'm just guessing. I don't know if that's it. Let's go look. It was kind of it's kind of a tradition. I think I'm going to do it every Christmas. Every Christmas we watch this entire video and make kind of like Mystery Science 2000 commentary on it because it's so funny. But so the Origins of Unix video, if you want to go find that, that's the video to watch. And the reason I bring it up is because he covers pipes in here. And so this is the guy who invented the idea of pipes. Yeah, there we go. Okay, wait, dude, explain to the folks at home how the pipe works. Mind blown. Okay, so it's just so funny. You go watch it. It's just hilarious. It's really funny. So I mean, the community was just hilarious, like cracking jokes. Pipes. So Unix is mostly about pipes. The power of Unix comes from the ability to chain the standard in a pipeline, the standard input from one thing. I mean, standard output into the standard input of another thing. Now, we haven't talked about how to get your own standard input yet. We will in a bit, but I'm kind of doing this backwards. But anyway, so it's like saying, okay, I want the thing that's coming out of this to go into the other thing that's going to wait around, and to have simple programs that do one thing well and integrate. That people leave that off the Unix philosophy all the time. The Unix philosophy is create something that does one thing really well and integrates well. And that's what pipelining has really become. It's really valuable for that. And so, for example, I mean, just a dumb example. I mean, I could echo 4 plus 5 to the BC calculator and get a number. We did this the other day with our pager. So anytime you use a pager, that's what you're doing. So you can say, pipe whatever, readme. So let's say I just want to get all of the headers out of my readme file. This is if you fail Markdown, simplified Markdown, then you don't need a fancy, generator or anything. You can look at all of the headers with one command, and then you can pipe that into more. So there's all the headers, right? Well, let's do another thing. So let's pipe that, and let's make an alteration on the input as it's coming. And you can use Perl or sed for this. I'm going to use Perl. So you can use Perl -e. Actually, no. Let's do. Well, I'll do something that you guys would probably know. So let's do a sed transform, and I don't do sed very much, so I don't like it. I would rather use Perl. But we're going to go ahead and replace all of the, I think we can try. I don't do sed. Sed has what's called basic regular expressions, which are a pain in the butt because they're not good. They're just not. They're not good. I don't like them. So there, sue me. And then what do we get? Okay, so that's pretty good for somebody to not remember it. So now let's take off the extra space there, and now we have all the headers. So we can send that to more. Look at that. I got all the titles, right? Here's what's even crazier. Watch this. Let's say I want to make a quick little one-line tool, and you can already see the power of this, right? Combining them. Let's send it to this select. Wait. So you can take all of that stuff and send that to something called select. So you could select title from, and then this big long thing, make that into a program. I know I'm losing you. I know I'm losing you. I didn't mean to lose you. But I want to show you this because this is really cool. So select title. Let's do T in, and we'll put all of that. You don't know about this yet, but what this does is it takes the standard output of a program and turns it into a variable. So you put $1 in and those brackets. So you can use standard output, the stuff that comes out of it, as if it were a variable. That's just so powerful. And then you do this. You use do echo $T, done. And now we just, oh boy, we need to change the input record separator. But you don't know about that yet. So ifs equals. No, now you're really mad at me because I went off the deep rails. There you go. And actually that put them all together. Well, oh well. You get the point. Hopefully. I was trying to give him all numbers. I tell you what, let's do number. What is the one that does the numbers, guys? Do you remember? It's I think it's ln, right? No, that's linking. There's another tiny command that will give you the line numbers, and I don't use it hardly ever. Is it num? Which one is it? How do I add line? It's some stupid easy one. I can't remember. I don't ever use it. Line numbers to stood out in Linux. Let's go see what the internet says. Said, no, we're not going to do that. There's actually a much easier way to do that. Cat, NL. It's NL. Pretty sure it's NL. Well, we're going to find out. NL. Yes, it is NL. Yay. So I still can't read it, right? So NL and tab. Now I can see all of the titles from this one thing by transforming them in a pipeline. Now, I hope I didn't overwhelm you there, but let's break down what's happening here. We learned grep the other day, right? So it takes the first item. I have to put quotes around it because it's a hashtag, and I told you the other day that hashtag is a comment. So that says, give me all the lines that have a hashtag in them. Now, I can get fancier if I know regular expressions, which you don't quite know yet. But if I wanted to, I could say, give me all the lines that start with a regular expression, and you'll get addicted to these eventually. And that gets more precise in case there's, and then it says, and then pass that through sed, which is a transformation. So sed and awk and tr. There's a whole series of commands we'll eventually learn that are just designed to transform a stream. They take in a line, they do something to the line, and then they spit that line out again, or they don't. And that transformation pipeline is what sed is really good for. It stands for in-place editor or syntax editor or something like that. grep actually, the RE stands for regular expression. Anyway, so this says substitute for any line that begins with a hashtag, or that any hashtag at all, which is probably not good. We should probably put the beginning of the line, remember? And then a space. It says replace it with nothing. And then pass that to another thing that just injects a line number at the beginning of the line. And then pass all of that to the more. And so I hope you understand that pipelining, this connecting, is super powerful. In fact, it's the most powerful part of Unix. I think it's by far, and it's also the part that is most easily overlooked by people who learn how to edit files. And I don't want to blow you away just yet here, but I'm going to just give you a little preview. So let's say you're editing a file. I don't want to screw anything up here. So if I'm editing a file here, I can actually use this idea of pipelining and putting things together in standard input and output in the middle of another session. So I'm editing right here, right? So I can say, I can do that same thing we just did. So, I mean, we're not really any place interesting, but if I wanted to, I don't know, anything. So if I wanted to take the scale, set the scale, I did this last time. I've done this like 5 times now. Set scale with the semicolon. So then I'm going to say 34 times 5.2. And if I wanted to pipe that to BC, I can write, see, but I'm in an editor. I'm editing a file in the middle of a file. And I can use a command that I won't get into to send that line to bash standard input. And it will, and it will run it and it'll replace it with whatever comes out. Whoops. Better than that though would be to send this line to BC, and that sends BC that line, and then it replaces it with the output. But I haven't installed BC yet. Did I not have BC on here? This is my stream. I didn't install it. Huh. Okay. Yeah. So let's. I'm sorry. I was on my workstation when it doesn't have it installed. I have to install. If you don't have it in yours, you might have to do app. You remember how to do this, right? Yeah. Apt install BC to get the calculator, and now I can go back and do what I was doing. What was I doing? Foo. Yeah. All right. So scale equals 2 divided by 2034, and then bang and pipe that to BC, and then you get a number. Now this looks like magic, but what it did is, I'm going to break this down. It took that line, and then I gave it a command, and this command says, this dot here, we haven't got into this yet, but the dot says, send the current line to the following command. The exclamation point means a command, and we give it a BC. So what it's doing is the same thing as the pipeline, but it's doing it inside of a program. And it says, now take the output of that and reconnect it to the standard input of this editor and replace this line with the output. Boom. You can use this to great effect. For I in 2 to 20 to 34, do echo I something done. Now that doesn't belong in an editor command, but if I pipe chain it to bash, I can replace that by sending it. So I'm using pipes inside of an editor. And the reason that this works is because all of the pieces involved, BC, bash, VI, they all play by the Unix philosophy. They all play by the Unix philosophy. So if they didn't, I can even put a bash command here, and I can run it. Because they all play by the Unix philosophy, the VI editor, which a lot of people misunderstand, they think, well, it doesn't have any plugins or anything. Obviously, it doesn't need any plugins. The line or all of the Vim buffer, it's whatever you want. And we're getting ahead of ourselves here. But if you want to read about VI Magic, please go see. There's a thing out there right now. I wrote a thing about the reason I had to make a whole thing about VI Magic because people understand. But the reason I brought up group, yes, you totally can. Yeah, it doesn't matter. It doesn't matter. I don't have Python on here, I don't think. But so let's do Python. Actually, that's in the video there. You can go watch. You can go read that. But I could be so. Give me the Python lines. What would it be? So for x, what is it? Print. Let's do a comprehension, right? X for x in range 1 to 20, 30 or something like that, right? Print. I don't know. I forgot how to do it. So no, we have to do it like this, right? Print X for something like that. I have to go look it up. I've been writing Python very much. So I can send that to Python. And if I did it right, no, I got an error. Oh, I don't remember my Python. How do you do X? Guys, come on, help me out with the Python. Do you guys remember the for X in range? X. I don't have it. It's actually on my thing. Let's go look it up. So yeah, let's do that. Let's open links. This is all, again, this is still related to standard input, or I mean to pipelines and standard input. There they are, the line one. So here we go. So there's the bash one. Yeah, okay, thanks. I missed it. So here's BC. I told you about that. Here's the printf. So that's there, and then I'll show you how to do all those. Okay, so why did I show you all that in the standard input video, in the standard output, in a pipeline video? Because the pipelines are what make it so magical. And if you throw away the power of the pipeline, you're not doing it right. You're just not. You're trying to do it like Windows or something. You're trying to put everything into an app and have the whole thing be in this big app that just does it. The Unix way is to do things that do one or two or three things really well and that integrate well, and particularly integration. So the theme for pipelines is not how to do cool things in VI. The theme for pipelines is how do I integrate things using the pipeline method of attaching standard input and standard output. And when you write utilities, you should be keeping this in mind. You should not just take, arguments or something or look at a file. You should be reading from standard output when possible, because this is adding these things up. You end up coming up with solutions for things you didn't even anticipate because you're just doing it right. Right. And it makes your vimrc when you get your editor is very tiny now, because now why? Now you're not obsessing over NeoVim's Lua and Java and Node support or whatever. You're just using Unix as God intended with pipelines. That's a good place to end the video. Okay, so next, okay. I do need to do this stuff on the actual thing. Well, let's get good to gig, get a job, get prepared to get a job, or whatever it is that you want to do, an occupation, a gig. Stream editor, right? How did I space that one? Thanks for John. Pope Stallman would be proud. Yeah, all of them would be proud. Ken is the one who invented it, by the way. Stallman invented Emacs, which is anti-Unix. Emacs is actually one of the biggest sins against the Unix philosophy. Because why? It's a monolithic application that's not designed to do standard input and output. VI does. VI actually is a visual mode of X editor, so you can actually do editing using the pipeline method with VI. You can't do it with Emacs. So Emacs is like you have to start it up, like VS Code, and do a thing. And sometimes that's the preferred way if you're editing lots of code, but it's not the Unix way. It's not. It never was. Which is funny because he gets all on people. So that's a pipeline. I'm going to use the pipelines. Let's do the hidden power and benefit. Ed goes to X goes to VI. Yep. Yes, it does. How's it going? How's it going, Bob? All right. So the hidden power of pipelines. In all things. So the more you connect things, the more they're valuable. I should probably I did reference the go watch Ken Thompson describe his idea. Unix idea. So I'm going to put that there so we don't forget. We're doing pretty good on time. Okay, now here comes some real fun stuff. FIFOs don't belong in here. FIFOs, they're pipes though, so I guess we should probably do them. They're like kind of the weird bastard children. See as a high, yeah. Did you did watch it, right? This high level thing. That video, that was one of the funniest moments I've ever had on stream with everybody. We were cracking all kinds of jokes. With the Model M on his lap and his feet is, I know. He's totally got his feet up. It's fun. I mean, you guys are really it's really entertaining. We're like making fun of the guy reading the prompter. He like takes like a full second in between saying anything. Oh, how's it going, Eric? Yeah, because he just like, oh, I can't read. He has to wait for the prompter. It has to render on the terminal. They're using some like Unix machine as a teleprompter, and it's taking so long to draw that you can hear the guy giving the presentation. You can hear the delay in his voice. It's crazy. Oh, standard input. Understand input. All right. So, hey, Eric, welcome. All right. So we're about to kick off another video here. So studio audience, welcome. And we're going to do, so not as fun until you know how to code. All right, so the next one, Python pipelines. So we just finished the Python pipeline video. You can go back and watch that. We marked it. We're going to do this. We're going to do input to your programs. I just did the VI thing, the VI magic. If you can rewind it and watch it if you want. I really think it's important that people understand pipelines. I just want to say it one more time since we have a new raid team. If you don't understand pipelines, you don't understand Unix, and if you're not using pipelines internally inside your VI editing, you're not using VI properly. Honestly, you're not. You don't know VI, and I'm not going to get angry, but there are people that rip on VI and they promote every possible alternative, and they don't know how to use VI with Unix integration. I call it shell integration, and they don't know it. They don't know it, and so they start ripping on it. And my only take on that is, before you start ripping on something and make something new, understand it first. Okay, post for life. I mean, because seriously, and I mean, I'm not going to go back and do it. Just go watch the video. Since you guys just rated, I'll send it to you again. But here is the Vim magic, rwx.gg vi magic. This gives a quick overview of this, and which is, I'm just repeating because we got rated a little bit. So this tells you why, and I'm pretty mean in there. I apologize, but so here's the line wand, right? You can use the wand. I call them wands because they're exclamation points. It's actually, once you learn how to do this, almost everything becomes an exclamation point. I don't even use visual mode at all. There's no reason to use visual mode. In fact, visual mode was somebody who didn't know how to use VI. Because if you knew how to use VI, you could send whatever you would do with visual mode to a filter command and do the same thing. And so, I mean, I do it all the time. So I have like so for example, people do comments all the time in VI, right? So let's say, like this, for example, right? So people will go into visual mode to comment that out. Do you know what else you can do? You can go to the beginning of the section, select the section, S keys. So we're going to select the section, boom, boom. We select the section and I send it to the shell and I put CMT, and that's a script that puts something in front of it. And to undo that, I just undo it. Otherwise I can do uncomment. I can do all kinds of stuff. The point is that if you know how to use standard input and output, you can write your own filter scripts and commands. This is also why aliases are the devil. I used to use aliases all the time. The problem is an alias isn't visible to the subshell of running VI session. So I know we're talking about VI later, but to those of you who have been here before, the bad part about aliases, I made a whole video about this, and you can go watch that, is because aliases you can't do that with an alias. If the alias is, it just doesn't work. It has to be a full sub process to do it. All right. Next video, and this will probably be the last one for tonight. I'm just going to go till 8:30. I like it. I like this nice digestible kind of comment, but this is some fun stuff, man. This is the kind of stuff I'm just going to tell you what to do, and then you can spend your extra, 2 hours tonight going playing with stuff, because it is just fun to play with. Okay. All right. So, new video coming here. Ready to go. So, we've talked about standard output. We've talked about standard error. Those are the outputs. And as a beginner, you immediately can take advantage of those things, whether it be just looking at a simple man page in a pager, piping it to pager, or it's a semi-involved pipeline where you're connecting the output from one program into the input of the other program. And I mentioned that in the pipeline video. Make sure you watch the pipeline video, because you won't be... one of the worst ways to get started is not to understand Unix pipelines. If you get out of the terminal and you don't understand pipelines, you're a noob. And it's like the single best way to determine whether you actually know Unix or you just never learned it. And it's whether or not you know how to use pipelines. Okay, next. So this video is about the last piece of this. And the reason this part is last is because it's not really useful to you until you know how to code, and that's called standard input. So input is the stream going the other way. It's getting stuff from the user in this case, and you can't do that unless you code it to do that, really. I mean, there's some cheap ways to do it, but as soon as we do them, you're like, why would I ever do it? They're really contrived examples. So I'm going to write a tiny little bit of code to show you how standard input in shell can immediately start working for you. But the important thing to remember is that anytime you have a pipeline, you are implicitly using standard input from one program into the output of the other program. So I'm going to use another dumb example. So scale, I'm going to make a calculator program. So 2, and I'm going to say, so what's 2 divided by 3? And I'm going to take that output, as we did before, I'm going to pipe it into the input of the BC calculator, which is designed to take one line at a time and read it and calculate it. And so that gives you the output. So the output at that point is that. You can even redirect this output. Remember we talked about that, right? Oh, that reminds me. We need to talk about T. We need to put T in here. Yeah. And okay, so we're going to go to BC, right? And that's just going to print right out. But if we wanted to write that to a file, we already covered this in the other video. We could say bc.out, and now it's written to a file. Okay, I can cat that file and do whatever I want. I mean, obviously these are still kind of contrived examples, but that might be nice, right? Because then somebody else might want to read from that file. Remember what we did with head? Head-1, we did this, right? BC out. Ooh, now I can look at the file. I don't know. Now let's make it into a big old thing on my screen. Oops, wrong thing. I wonder if we could do Figgle. I wonder if Figgle will work. Yep, there we go. Ooh, look, it went to Figgle it. It did it. Yay. So now let's clear the screen and do that whole thing. And now we have a .66, right? All right, let's make it repeat, shall we? I mean, it's never going to change. You know, you could, right? So you can make really simple programs just by combining all these things together. That's the Unix way. Make sure you get that. So, but here's another thing you can do. Let's say, so we're focused on input here, and I'm trying to show you that BC takes standard input. So BC takes standard input, but there's another way to do this. If I want to, I can do this. I can do T. I can pipe this to T. Now T is a special program we didn't talk about in the other video. We should have. That actually will write to the file and also pass it along. So the thing that's really great about that is when you build up your pipelines, you can have different things accepting standard input and also writing what they know about at that moment. So you can like sort of, you know, if you can visualize this, you can kind of read stuff and then dump that, dump that, dump that. You can have multiple values being written at the same time. It gets really powerful really quickly. And this is the reason that hackers love Unix and Linux, because they can create extremely powerful combinations very quickly. Overthewire.org. Go play it. You'll love it. It's really fun. Start and play Bandit if you can. It's got a lot of this stuff in there. So let's talk about standard input though again. BC's power is it reads the input, T's reading input. The power of all these programs is that they read standard input. And there's really no way to show you how to read standard input without writing some code. So I'm going to write a quick little program that does this. So let's say, well, I mean, there's just so many. The easiest way to read standard input, and I'm just going to put this in here too, is the read command. Okay, so, well, so first of all, we should probably show you the file and direction. Yeah, let's do that. Let's do that. And then let's do, then we'll do the user read. Let's see, -R with that. To read input. I'm going to get rid of the -R so you can look at all the options. All right, so let's talk about that. So let's say you wanted to take the output of that bc.out. What if I put that echo into a file? Let's do that. I'm trying to find ways that are not programs. So if we did that, we could write this to, let's do that to bc input. Okay. So now what? Now, how do we get that input? We can cat bc.in. We got that file, right? And we can cat that file, and then we can cat that into BC. You see what I mean? Now, what I just did right there is an anti-pattern, and you should never do it. That's the first and only time I want you to do that, and never do it again. The only reason you did this right now is because you don't know about the next operator, and there are a lot of people on Stack Exchange who have no idea how to do this. Some of the most popular answers on Stack Exchange are dead wrong. You should never do it, and there are lots of bad consequences if you do it, and I'm going to get to that. So what this does, every time you pipe to a program, we talked about processes many days ago, but it creates a process underneath another process. And every time you put a process underneath another process, it creates a different memory space, variables and stuff like that are in there. And when you pipe to a program, that program loses visibility to its parent unless the parent has exported things. Now we're not going to get into that until we get into shell scripting, but just take my advice. Never, ever cat into a program, ever. It's the worst possible thing to do because it makes your program blind to its environment. That goes for while loops. That goes for everything else. And it's rampant on Stack Exchange. And now you know not to do it. So the replacement is this. We can take that and we can say, I want to send in that file, bc.in. Much easier, right? And the thing that's really cool about that is because it didn't cause it to be a subshell or a subprocess, it can now see its entire, stuff on the outside. It's also simpler to write. And there, I'm just showing you the POSIX shell right now. So in case anybody actually knows more than this, Bash has taken this idea of input and just gone crazy. You can actually input commands. You can input strings this way. They even have, I'm not going to show you, it's just going to confuse you. So just the one operator for now, just read in this input line by line and put it in here. The only time you might want to use cat would be if you wanted to have two files together. How do you keep piping this? Same way. Yep. So yeah, you just do this. You just do bc, bc.in and pipe that into another BC. How about that? Or you can pipe that into, what do you want to do? How about, you can do xargs. This is crazy. You guys haven't learned this one yet. Printf value is s. Remember I told you about the command line? How about that? Isn't that cool? Xargs is cool. We haven't learned about xargs. Should I teach you guys about xargs? At what point do we learn about xargs? It doesn't fit anything else. Probably in the pipeline conversation. What do you think? What do you guys think? Should we do that in the pipeline conversation? I think we should probably do T and I don't know where to put it. Probably here. Yeah. Okay. So use xargs to transform output into arguments. All right, so there we go. So we're gonna do the here. We got some time left on this video. I think we're gonna make it. So that's what xargs does. I'll have to cover it in the video, but this whole block will be good. So what that does is it takes each line of output, at least the first line of output. Actually, I think it crunches all of the output and just combines it with white space. So you probably don't want to deal with too much in there. And then it sends it as arguments on the end of printf. And since we learned printf, now you know you can actually make it into a total. So if I wanted to change, I can make that into a program, by the way. So if I put some other stuff in here, right, put some like times 9,000, now I can run that same program again. And you can tell where this is going, right? Because this is already a program. And this is why we're learning shell programming first, because it's so easy. So all I have to do to make that a program is to say, I don't know, calc. There's already one taken to call that, but we'll do it anyway. Bin sh, and then paste. And now we have it. We have a program. Chmod the thing, give it, turn it, tell the computer what it's a program, and run it. There you go. In fact, watch this. We can use our output again. Check, this is going to get weird. This is going to get really weird really fast. So, well, we probably can't do that. I wonder if we can. If it's a separate line. This ought to be interesting. Let me try something. Echo divided by, I'm just having fun. Divided by 234, and write that onto the end of our input. And let's run our calculator again. Oh, syntax error. Damn. We were pretty close. I was afraid, so we had to change it. Run the calculator again, and now we got a different number. You see how quickly and easily it is to put together scripts and utilities using shell? And this is just the beginning. I mean, we haven't even touched the top of all the amazing things you can do with shell input. So we have to get to even some of the more fun parts about this. So remember I said about reading input? Well, some programs will wait around and wait for input. And many of them do this. So we can actually make our own to just read input though if we wanted to. I mean, in terms of like echo. So we can do echo, but like let's say I want to echo a lot of stuff, right? Actually, more importantly, let's use yeah, echo is kind of a hard one, but so if you use 2 of these, remember 2 for out and 2 for in, and then but to do this you have to put a letter, you have to put something here. The end is here. Yeah, they're okay. So in general, you should use echo when you want to have something just print out an extra line. Printf is more precise, never prints an extra line, never prints an end of line unless you tell it to. And but you know, like echo-n is not POSIX, so don't use that. A lot of people do, but I would not get in the habit of it. So you can do echo the end, and what that does is it waits around and says, hey there, I have something, another line, and it's waiting around. What's it looking for? You can probably guess. The end. All right, and it actually didn't echo it. And this is one. Let's try Printf. Let's try this one. Here we go. All right. Oh wait, we need something here. So that is actually printing it. I know it doesn't look like it, but it is. So it's printing it, and I think I'm confusing my Python syntax probably. But so anyway, if you I'm trying to decide how it was the best. There's really no way unless you're doing it into like a file or something. So if it's as easy when you want to do a variable. So you do a variable. We haven't done variables yet. So if we say var my whatever my poem equals end, right, and that'll wait around to say something wicked end. And then I can do echo poem, and you get nothing. Why don't you get anything? What am I doing wrong, guys? I'm missing something. I don't know what I'm missing. I don't know what I'm missing. I'm missing something really simple. I did that the other day with BC. I forgot to put a semicolon, and I spent like 20 minutes. That's a here variable. It's not 3, right? Because that's the whole variable, right? I don't use this very much, but let's try it again. It should be fine. Is it because we didn't export it? I don't know what's going on there. Someone's got to help me out, but that's a here variable. Let's go see. Well, when in doubt, go search it out. Here docs. Those are called here docs. So here you go. So here is a here doc. Lol. You do that, and Unix shells that have them. There you go. See, that's what I'm doing. It's just not working. What's that? Did I do it wrong? See, here's how you do it though. See, that's sending all of that stuff to the end. I don't think I need to export. I don't think so. So there's the cat UF. That's what we just did. We just did that thing. Oh, I know why. Because it sent it to standard input. That's why. I keep forgetting. That was the whole point. Well, good. Now you learned my lesson and you know the difference. All right. So we actually want to do this. We don't want to echo it. We want to cat it. Because why? Because cat takes in standard input. Remember? So echo doesn't. See, watch. If I do echo something to echo, it's just gonna like fail. So echo, I keep forgetting. This is probably a good thing that I forget it, that I screwed this up. It's like my Mr. Rogers sets up a tent moment. So don't confuse arguments with standard input. That's what I just did. So what you want to do, if I send this to cat, that'll put it out because cat takes in from standard output. Echo doesn't. Echo doesn't care about standard input. Neither does print. So that's why none of those worked. Print is for printing something that is output. It's for printing an argument, right? So if we do this, we do cat. Remember we did cat before. So if you wanted to just cat a file, cat bc.in. right? Well, if you don't have the file name, you can replace the file name with this. And you can say till the end of something, something here, I swear, or something. I don't know. EOM. And then it prints it out. Okay. And you can combine these. So you can combine these just like you can combine BC. And it's a little bit harder to do though. So cat, this is actually really hard to do. You can pipe that into NL, which gives us a line number, right? And that will wait around something 3, 4. Let's see if I did it right. And then EOM. And there we go. Something 3, 4. All right. So that's reading from standard input. All right. And yeah, I should probably put a note in here. Don't mix up arguments and input. So we're going to put arguments to be like echo, right? Cat. And while we're at it, we should probably tell you about something called rev or tac. We talked about that the other day. You know about tac. Tac gives you the whole thing backwards. And if you do rev, it'll reverse the whole thing. So now you have the whole thing backwards and reversed. If you want to see secret messages, the environment export without export is gone. No, you don't ever need to export a variable unless you want a subshell to see it. And we'll talk about exporting variables when we get into coding, but that export was not needed there at all. Okay, so next we got, what's the last thing we have to do? We have to do, read. Okay, now read is what makes you have your interactive story game. And a read-p, which is only bash, POSIX does not have it, so we're not going to do it. So let's combine these two things. It's really good to combine read with a printf. So you can do printf, which doesn't have a line return. You can say, I want a printf. You don't need arguments, and then a semicolon. That's two things on one line. You can say, is that okay? And you could say default of no, and a space, and then just put read. And it's like, is that okay? And you say yes, right? And then if you add, we haven't done variables yet, but if you add a word, it will put whatever the answer is into that variable with that word. So you can say read response, okay? Yes, right? And then actually after you read the response, you can echo the response just to the screen. Is that okay? Yes, sir. Yes, sir. So that is your prompt right there. Now that's the way you should do it. Now, if you know you're writing in bash, if you know you have bash, and I think you should stick with the POSIX personally. But if you know you have bash, then you're going to be writing prompts like this all the time, because this getting interactive user input is a thing. Now, there's some schools of thought that say you shouldn't ever prompt for interactive input because it blocks. Your Unix-ness of the thing is blocked because now it can't be put in a pipeline because it's going to slow the pipeline down, and now it can't be put in an automated session. So if you do, in fact, that is such an issue. Blocking standard input is such an issue. Check this out. That there has been a program called Yes created, and the only thing Yes does is send the letter Y over and over as fast as possible. That's all it does. And my fan just came on. So you could do just about software checking bashes on the script. Shell check. Yeah, shell check. So if you're off to shell scripting land, make sure you have shell check. Shell check is your friend. That will tell you if you have a POSIX script or not. And you don't want to write non-POSIX scripts if you can help it. If you're going to great pain, you likely want to grab Bash or Perl or Python or Go at that point. My favorite these days right now is Python. I mean, is Perl for rapid prototyping, but you can prototype pretty rapidly in Go too. But POSIX shell again is the language of the container world. You know, Docker files are written in it. So you need to learn POSIX shell first. I cannot overstate that. I see people doing things like this all the time. Make directory -p, some long ass directory name, and they get to that's really cool and all, but that is not POSIX. So they get on a POSIX machine, it doesn't work. The equivalent app, by the way, this isn't about standard input anymore, but so the equivalent of what I just did, by the way, so if you want to do that same exact thing, you kind of have to build it up. So you have to do make dir some long, and then keep going. It's not nearly as elegant, but it works everywhere. The other one doesn't. And shell check will catch that. So in case you're worried about doing something that you're not supposed to, everybody should be using shell check. Okay, so all of that is well and good, but read. Let's go back to read. So as you saw, read. Where's the one that had the answer? I want to finish my thing with yes. So if you want to automatically answer this question with yes, check it out. You can do yes and pipe that into the whole thing. Oops. Let's make this into a program by putting parentheses around it. Oh man, I'm still messing up. Oh, I don't think it's going to work until I put it into a program. I mean, let's put it into a program. All right, so prompt. I mean, you're going to do edit. You're going to do VI soon. Don't worry. I killed it. I did. I killed it. Damn it. I was going too fast. All right, wait. Here we go. So I'm going to use my mouse. Don't yell at me. I didn't say I'd ever use my mouse. All right, so there we go. Make it into a script again. You're going to get used to making scripts. Bin-sh, right? And it magically transforms. I can put these all on a separate line. Is that okay, right? And the thing that's cool about this is you could say, well, you can test if the response is equal to y, and if so, it'll say yes. So now we have a script. I can't stop making them because it's so easy to make them. So prompt, is that okay? Yes. Uh-oh. Well, I tried to minimalize it. Oh wait, that's a number comparison. And truth be told, you should wrap this in double quotes, but we haven't got there yet. So prompt, yes. All right. And watch, I'm going to actually, after it's done, I'm going to echo the last return value. Is that okay? Yes. 0. 0 is true. Is that okay? No. 1. So now I have a script. And if you know what, that's a perfectly good script. This is a perfectly good script. Haskell's great for parsing stuff, by the way. So this is a perfectly good script. Maybe you just want to throw prompt into something. Because now you can actually do a test. You don't know about test yet, but you can actually do this. You can do test prompt and echo yay. Test prompt and echo yay. Oh wait, we have to run it first. No, we have to do prompt and echo yay. Prompt and echo yay. Plain. Oh, I messed up. Right, which prompt? Oh, it's using my other program. I have another program named prompt. So there we go. Prompt. Is that okay? Yes. Yay. Prompt and okay. No. There. You see what I did? I just took a few things, put them in a file, and now I have a thing that I can use with something else. That's the Unix way. That is standard input. It's a good starting point. It is. It's a really good starting point for starting to use and or and that kind of thing, which, as you can tell, is getting us very close to shell scripting. What I'm trying to tell you is every single line you're writing on the terminal is code already. You're already coding. Even if you just type echo, you just type ls, that's coding, because you put that in a file and it's coding. Okay. There's a lot more we're going to be doing with standard input and output, obviously, as we get into it. And I know you're anxious, but we need to do another video about FIFOs, and that's the end of that video. 8:31 though, it's probably time for us to go. You know what? I'm not doing FIFOs. I'm not doing them. They're not beginner tech. FIFOs are not beginner tech. In case you want to know, a FIFO, if you do make, is a special command for it and everything. A FIFO is a file that is a pipe, and you can attach, you can read from it just like you read from a file, and you can write to it just like you can write to a file. And when something reads from it, the thing that's writing to it will be unblocked and it will pick it up. So you can actually have two programs connected to a pipe that's on a file. But I'm not going to cover it officially in the boost. If you want to go down that path and go look for it, that's actually, you see all my WeChat that's coming out? That's how I send stuff to WeChat. So WeChat is just a file. Remember I told you everything's just a file? So if I want to send something to the WeChat, I send it to the WeChat FIFO, and then it shows up in the WeChat, because the WeChat program is constantly listening to that FIFO to see if there's anything there. And if there is, it'll write it to the chat. So it's an advanced technique that we probably only want to do once you've learned to script and stuff. So, but there's just so much more to know. This is the minimum you need to know to become productive. Those other things are going to be things you're going to need to do over time. That actually puts us down pretty good on the time. I'm going to go ahead and wrap it up, and then we'll start with managing users and permissions tomorrow. And we did processes and jobs somewhat yesterday, but we need to come back and do that. I really broke these down into smaller pieces, so that we can get into this stuff. And so we're like 3 days before, we'll get to, what is that? So today is, what's today? Today's the 10th. Today's Tuesday. So Tuesday, Wednesday will be manage users, Thursday's manage jobs, and Friday will be VI. And that's good, because that means all weekend long you can practice VI. You're going to need to practice VI a lot for at least 3 days before you can be even minimally productive in it. It's terrifying when you first do it. I remember doing it. I remember I switched over from Joe and Pico in like 96, I want to say. And it was pretty damn scary. So once you get that, we're going to talk about basic networking, remote access. I feel like we should go back to writing code. I kind of want to start writing shell script right there, because you guys are all ready to go. You got all your stuff going on there. I feel like we could do a shell scripting thing right here, but I want to get you used to Tmux first. And actually, we should probably do a shell configuration at that time. Yeah, let's do that. Let's do, I'm gonna change this. Before we do networking and after you learn VI, let's do shell customizations. Yeah, we'll do that for Friday. That will be for Monday, actually. So Monday, customize your shell. All right. And people will be lost doing that. But now that you have VI skills, that will make you immediately, oh, you know why we don't have customize your shell yet? Because we haven't learned shell scripting. That's why it's not there. This is always the hard part for me to decide. Every year I go through the same problem. It's like, your commands are code basic shell scripting. So we have that on day 12. Maybe we should jump ahead. Anyway, this doesn't have to be on the stream. I'll do this on my own, and then you guys can just keep that. What's the URL? github.com/rdbxrob/boost. Yeah, we'll do that. We'll do some shell scripting right away. I just think it'll be more fun because people like the code, and they'll be coding by day 14. So that's good. And then everything else is just building on that. I mean, networking and everything. Because I've already written so much code that it's, yeah. Okay. Who we got there to raid? Is Mastermind still on? I have to go raid him before he raids me because I don't want him to raid me and make me have to stay here. I love the pickup scripting. Well, last day I made a script to set up a process on my PC to high priority when it was often lag, VR related, on the normal setting. So I just run a script and I don't need to ask the task manager. Isn't that great? Isn't that great? And you put him in cron, which we don't have yet. We need to put that in the 2 basic shell scripting. Yeah, where is it? No, we need I can't lose this. We need cron. Where do we put cron, people? It has to be after scripting. I think we could put it in customizing your stuff. Yeah. Customize cron. Yeah, I'm gonna come back and edit that right now, so we can get it in order. This is I know this seems loosey goosey the same way I've been doing it for 8 years. Every single time it gets better. It gets slightly modified. Let's find somebody fun to raid. Are you in POSIX? Put Bash on there if you want to. Kulisok. I'm not saying don't. I do Bash too. Bash and Perl and Python. I do it too. Just make sure you know POSIX, or you at least know where shell check is, so you can make sure the stuff you're writing is POSIX. -P on Bash is not enough. It is not a shell checker. It is not a shell checker. World of Warships does not interest me at the moment. Oh hey, Interstrager. Try hack me, Bash Bunny. She changed to track me. She was doing some why are you in a NitRAM FS? Are you running a container? The search is else today? What? Yeah. Let's see. Figured I might be on a 6-month break because I moved to the US. Yeah. Learning over 6 months to pick up a job. Coding. Definitely containers and DevOps. Containers, DevOps, and Cloud Native. Those are super employable right now. I mean, there's jobs constantly. I have a recruiter right now who's got 2 positions unfilled. If you know how to do it, I can send you his stuff. We have 10 people get jobs. Nice. Let's go raid Learner Leon. He's awesome too. He raided me the other day. We're all kind of on at the same time, so why am I not following? I was following him for a while. What happened to that? It must have been one of those days when I just was going off. I think it was front end related. So I every time I hear people who are doing front end stuff, I get annoyed. So I'm gonna go ahead and raid Leon. Thanks, guys. You're using double brackets. That's not Bash. You can't do that. Cannot do that. No, you cannot. You cannot do that. Wait, did I not rate him? It doesn't say hosting yet. Did it go? Did it raid? Oh, okay. That's weird. I mean, usually it says hosting down here right away. Maybe it's just cut off. Oopsie. It's good to see you, Ball, soon. That feels really weird to me. It feels like the raid didn't go through. Unless he blocked raiding. Yeah, I was gonna say it didn't. It didn't. That was really weird. I it's. Oh no, there it went. There it went. Yeah, it did. It should. You should be there now. All right.
It's magic. I don't know how you do some of the things that you do, but I love to watch you do it. I think I literally typed in chat like my mind was blown. The stuff they had going in their terminal was just bonkers. So definitely, please give them a follow. I don't know if we can put their link in chat here. Let's see. Let me grab it real quick. I forget, do we have the shout out command? I don't know if we have shout out command yet. There we go. Boom. I'm like over here trying to type it. There you go. Thank you, Alyssa. Please give them a follow and go watch them when they're live. Your mind will be blown. They do things inside the terminal I've never seen before, and they explain things really, really well. Thank you so much for the raid. Hope your stream went well. What are y'all working on today or doing today? No worries. Night. Have a good one. Peace. Thanks for stopping by. Thank you for the raid, everybody. We are talking right now. If you're new, I run a 30-week software engineering boot camp.
I mean, if you're still here, I absolutely love Leon, but there was a day I just lost it on front end stuff. You know, it seems like people associate front end stuff with all there is out there, and that kind of got me annoyed. I think Leon took some of my angst without ever knowing. I didn't directly target him or anything, but I just remember seeing a bunch of front end people streaming that are getting a lot of attention, and that's awesome. But I'm also frustrated because people aren't paying attention to the core skills that are needed on the server side. You know, it's a terminal and stuff, and so it looks really magical to everybody when in fact that should have been the thing they learned first. So that's where that's coming from. Bye.